3.
Huh? Number 3. Let's have a look. So, maths part 1. No, what am I saying? Maths part 2. So, functions and transform functions, yeah. Right. Number 3, is it? Any particular one, or just everyone?
I tried number H.
Right, I'll do it, so. H, you said? Okay, let me write it down.
Y equal
Thank you.
minus 1 f 3 over 2 x, yeah, minus 3 bracket minus 4
And the point?
minus 7 minus 5.
Okay. So, here we'll write it like this, Mishri. I should take the 3 over 2 out first.
Minus
2. Yeah. So, your A minus 7 minus 5. Firstly, the minus here flips the y. So it becomes minus 7, 5.
What x-axis?
No, this minus here flips on the y.
I think you said the opposite.
No, the minus here flips on the x-axis. Anyways, let's see if we get the answer at the back. This compresses the x-axis by 3 over 2 units. So divide this by 3 over 2. That's like multiplying by 2 over 3. This moves it to the right 2 units. So add 6. Well, add 2, which is a 6, which is minus 8 over 3. And then finally this moves it down 2 units.
See.
I think I made a mistake. Well, let's see what the answer is at the back. Which one was this? H. Minus A over 3 and 3. No, that's right. No.
I didn't take this class though.
Yeah, but Mayor, you know I record lessons and upload them. In ESAP today, I told Dennis to give you time to work on your lab report, and he said if you have some English questions or grammar questions, he can help you with that.
Yeah.
Got it? Yeah. Anything else from last week? We'll start the next lesson? Yep. Okay. So our next lesson, I think it's called Modulus function. It is Modulus. I think it's also the last lesson in this chapter as well, isn't it? Yeah. Yeah, it is. Okay. Breakfast? A kind of breakfast. No, I'm actually quite full. Thank you. Are they playing? My favourite's salt and vinegar. It's nice.
Onion.
Cheese and onions good. Paprika?
Only like this one is like, what is it? The salt and vinegar is like too much salty.
So boring. No flavour.
It's for free.
Oh, is it? How'd you get it for free?
In the shop.
Oh, you stole it?
No. I know that.
No, I know. Yeah. You got it from the petrol station, was it? Yeah.
A treat.
A treat. You did a good job, did you? Yeah. Now, modulus function. Modulus function, we write it like this. It's actually also called the absolute function is the other name for it. And what does it mean? I think Mushariki. Huh?
The modulus function or the absolute?
They're the same function, they just different names. I think this is more
anything with the mod?
Ireland and this is more US. So, do you know what it means, this one? I know you do. Do you know this function? Have you seen it before?
Like, when there is a mod, anything, the sign inside will always be positive.
So, it's x if x is positive, and then it's minus x if x is negative. In other words, it makes it positive. If it's a negative, you put a minus in it, makes it positive. If it's positive, you don't do anything. Okay. So this is the definition of the modulus function. You might want to write this down. And I should actually also specify x can be any real number here. Yes, got that? Yeah. Mir? Maybe. How's your lab report going?
600.
Not bad. Not bad. Halfway done nearly.
Yeah.
Have you done the calculation part? Introduction?
Procedure.
Procedure. Yeah. Okay, can I scroll down? Next. So I probably want to look at how to solve these. Yeah, okay. Maybe we'll take an example. So how to work with these. Well, actually, before we do, one thing you need to know. If I said, for example, the modulus of x is equal to 4, that means x was equal to plus, or could have been minus. So we actually have two answers here. But it is possible to have no answers. Or not no answers, I mean one answer. Modulus of x equals, what do you think what I need to write here to make one answer?
0.
Yeah. That means x was only 0. Yeah? You understand? Yeah. So that's the first thing. And the second thing which is useful the modulus of x squared is the same as the modulus of the square of x, which is actually the same as x squared. Now the reason that is this makes it positive, this makes it positive and squares. This makes it positive, and then you realise, oh, and this makes it positive and it makes it squared. But you realise, well, then I don't really need to have this here because it's already positive. So in other words, a way to cancel a modulus is by squaring it. Yeah? Okay, so you might want to write these two down, and then we'll have a look at some equations to solve. Oh, and sorry, before you write this down, what would I need to write here so that it has no answers? As an example. Now it has no answers, because it's impossible to make this true. Why is it impossible?
Because it's in plus and minus.
Well, no, more precisely. What does this mean?
Positive.
And what's this?
Yes.
It's like saying x squared equals minus 1. You can't solve that one. Yeah. Yet. Okay. Got that? Now, let's have a look at our first equation. Minus 4 modulus x minus 3 equals minus 16. So there's two ways to solve this. I'm going to show you both ways. So the first way to solve it, well, first we divide by minus 4. Then we get x minus 3 equals to 4. So that means x minus 3 must have been plus or minus 4, which means x minus 3 equals 4 and x minus 3 equals minus 4. So x equals 7 or x equals minus 1. Right, that's the first way to solve it. Write that down and then I'll show you the second way. You sure?
Yeah.
Yep, okay. Second way to solve it, it looks like the same at the start. I'll just clean it up by dividing by minus 4. So I get x minus 3 equal to 4. Then this is where it's different. I'll square both sides. So the modulus actually is gone when you square. So I can just make it brackets. In other words, I can change this into this.
And then you take a square root.
Then I square it. X squared minus 6x plus 9 equals 16. X squared minus 6x minus 8. No.
You can.
Wait. No, not square root. This is not what I want here, because then that's just going to be like the last method. 7 minus 7, isn't it? So then you have x minus 7, x plus 1. So then you have x equals minus 1 or 7. Same answers then. Yeah. No, not the square root here, because the square root would make x minus 3 equals to plus or minus 4. And you're kind of doing it the same way then. All you've done is you've added in extra steps in between these two lines. Do you know what I mean? So, yeah, write this one there. Got this? Yeah. Okay. Now, let's have a look at another one. So now, let's try to draw this. Y equals minus 4 modulus x minus 3 plus 16. Let's try to graph something like this. Okay, before we graph that, on the side, let's graph this. Does anyone know the graph this one makes? Just a modulus of x, nothing else. What shape?
U?
Quite. B, like this. So this is the shape of modulus. Okay, so you might want to write that down. Then we'll have a look at the more difficult graph. Yeah? Okay. Ready to look at this one? Now here's the trick. I've changed this. Well, not that I change it, but if you think about it, if I say f of x is the modulus of x, then this is minus 4 fx minus 3 plus 16. In other words, it's like you take this function and transform it into this function. So, watch this. We'll do it step by step by step. We'll start off with the modulus of x. Right, what does the minus 4 do? Well, what does the minus do? What's this minus do? Yeah, upside down. So, and then the 4, what will the 4 do?
2, 4, and minus 2.
Not quite. It makes it 4 times bigger. Like this. And what does the minus 3 do?
Move it to the right.
How much?
3.
So it's over here now. And then what does the plus 16 do?
Move it up 16.
Yeah, so then here at 16, this gets moved up. Oops. So in black, this is what I should get. Now, I'm going to draw this in the graphing program. Minus 4. Wait, before you write anything down, where's absolute function? ABS, I think. X minus 3 plus 16. There you go. Now let's look at the graph. I think I have to zoom out. Yes. There we go. What am I doing? This is like what I drew. See, it goes up to 16. It goes up to 16. You get it? Yeah. Okay. Now, there is another way to draw it. So, like I said, there's two methods to draw on it. So, if you want to write this method down, or try and write this one down, and then I'll show you the other way to draw it. Okay. So I'll just give you a minute to write that down.
It's at f of x minus 3. So we move it like to the right. Because of minus, or if it was plus?
To the left. Got it?
Yes.
Yep. Great. Let me show you the second way by using the same function. So we do it like we did in semester 1. First we find out where it crosses the y-axis. So how do we find that? Do you remember?
Y-axis.
So then you get y would equal minus 4 modulus minus 3 plus 16. So that would be minus 4 plus 16, which is 12. So the first point is, first point is 0, 12.
Why
what?
cut the 3?
Yes, that is a good question, because I'm tired. That's why we cut it. Hi. Minus 12 plus 16. 4. That's better. 0, 4. Now, how do I find out where it crosses the y-axis? The x-axis. let y equals 0. Yeah, so we get minus 4 equals 0. So we get this. Now, did we learn how to solve this? We did.
Yeah.
We did it earlier. In fact, we got two answers. What were they? 1 and
minus
1 or 7. So now you have the points minus 1, 0 and 7, 0. Okay. Lastly, we should find where the turning point is, because what I mean by turning point is this point here, the maximum or the minimum. Now, because this is a minus, just like with the quadratic, is it a max or a min?
Max.
It's a max, just like with the quadratic. And also like the quadratic, this is interesting. You remember you had y equals ax minus b squared plus c. The maximum was at b, c. Yeah. But if I had y equals a absolute x minus b plus c, or something like this, again, it's still b, c. Because the reasons that this is the maximum for this are the same reasons this is the maximum for this. This can only be positive, the smallest it could be is 0, etc., etc., etc. So, by just looking at this, we can clearly see that the maximum is at 3, 16. So if we were to try and draw this, what we'd have, a point here at minus 1, a point here at 7, a point here at 3, 16, which is the maximum, and these are the roots, and then it crosses the y-axis at 0, 4, which is here. This is the maximum, from the maximum, down and down. In the exam, sometimes they want it this way. In fact, most of the time they want it this way, because they'll ask you to mark the vertex, the roots, and the y-intercept on the graph. So this is probably what you would need to do for the exam. Yeah, okay, so write this method down.
And it's easier.
Depends on your personality and what you prefer. Some people maybe, other people no. Got it? Mm-hmm. Yes, Mayor? Yeah? Okay, what else do I need to show you? Inequalities. Not too bad, I don't think. Okay, let's do something like, well, you know what? Let's just keep using the same one. So let's say I want you to solve minus 4 absolute x minus 3, let's say plus 16 greater than or equal to 1. Okay. So how can we solve something like this? Let's try. So we have absolute x minus 3 and then the minus 4 greater than or equal to, do you know what, maybe I'll make it a little bit easier by making that a 4. So then that would be 4 minus 16, which is minus 12. And then that's absolute x minus 3 greater than or equal to 3. Yeah? Yes?
You have to flip that side.
Very good. You're more awake than I am. Okay, I need to fit the signs, yeah. Okay, what to do next then, since you're so awake?
You come really equal it, like.
I know what you mean, yeah. Do what exactly though?
X minus 3 equals to minus 3 or?
Not quite that. Not quite that. What do you think? Here it is.
I think it's 3 on minus 3.
Could square it again. Do you know? You could square both sides. Yeah? You would get x squared minus 6x plus 9 less than or equal to 9. X squared minus 6x less than or equal to 0. X minus 6 less than or equal to 0. 0. 6. And which part do I want? Above or below? Above or below?
Down.
Below. So x has to be between 0 and 6.
How do you know that we have to?
Because we did this in semester 1.
Yeah, but
you forgot. Or you weren't listening. So if it's less than, it's under, and if it's more than, it's above. You could watch my video again.
yeah.
Now, if you think about it, I'm saying another way to do it is you could draw this. Yes, you could draw this and then see when is it bigger than 4. So here's the picture for it, and here's 4. So if I draw a line, you're saying that this will be bigger than 4 between here and here. This is 0, and this point here you could see from the graph is 6. Now, of course, this is a bad way to do it because the graph is maybe not accurate. But it's just another way to do it. Probably shouldn't do it this way in the exam. This would be the best way to do it in the exam. But it's not the only way to do it. Something you were saying earlier, kind of, you can do here. So if you write this down, we'll look at the other way, okay? Got that? Okay. Let's have a look at the other way to do it. Got that? Right. So you can say minus 4 absolute x minus 3 greater than or equal to minus 12. Absolute x minus 3 less than or equal to 3. Let's draw a number line. 0, 3, minus 3. Now, I'm not talking about the x, I'm just talking about this part altogether. So let's say, for example, this was equal to 4. What's the absolute of 4? The absolute of 4? 4. Yeah. Okay, absolute of 5. 4? 4 as well. These are too big because we need this to be smaller than 3 or equal to. Well, absolute of 3? What is it? Absolute of 3 is 3. This is good. So 3 is good. What about if the absolute here was 2? Would that be good or bad? Good, because it's less than 3. So 3 is good, 2 is good, 1 is good. 0? Yeah. If this was minus 1, what's the absolute of minus 1? 1, which is good. Minus 2? Good. Minus 3? Good. Minus 4? No good. So we need this to be smaller than 3 and bigger than minus 3. But you've seen these in semester 1. If you add 3 to both to all parts, you'd get 0, x, 6. The same answer as here. See? So, again, another way to do it. So there's many ways to do these questions. It's whichever you prefer. Yeah. Okay, can you write this one down?
Why there are so much graphs?
Graphs are good. Pictures are good.
No graphs.
How will be the physics system like?
No, like graphs, these things,
I know these are great. Okay, Mr. Reed, we have our usual deal. Half of your time and then half for my time. You don't look as cold this Monday. Got that? Got it. Okay. Oh, sorry, Mr. Reed, do you need to write this down? Now, let's see. The questions get very interesting and difficult towards the end. So 1, 2, 3 and 4, they're alright, they're fine. 5 and 6 get a little harder, and then 7, 8, 9 and 10 starts to get very tricky. They're good practice for the exams. Basically for the exam, really it could be anything from 1 to 10. Yeah, except, yeah, no, it could be anything from 1 to 10. So it's kind of odd because sometimes this question is really easy in the exam. They just say, oh, draw this. Something simple. But then sometimes it can be really difficult. But on balance, it's usually not difficult in the exam, on average. Yeah. So I think what we'll do is we will have 2 lessons because we're finished this. I'll just give you some time to work on it now for a few minutes. The next lesson is not too difficult because it's the start of a new chapter. Yeah. Any sign of Iyad? No message from him? He didn't send you a WhatsApp? No, Iyad? Okay. I'm going to close the video now.